Hi there. There is actually another algorithm called Kruskal's algorithm, which can also find the minimal spanning tree or minimum spanning tree of a graphal network with n nodes. Just remind ourselves what a spanning tree was again. A spanning tree is a connected graph that connects all the nodes without any cycles. The minimum one is the one of smallest weight. In the previous video, Prim found a way for us. There was a Prim's algorithm using graphical means and matrix method that found a minimum spanning tree. Kruskal does the exact same thing, just via a slightly different method. And here's how he does it. So Kruskal's algorithm says to find the minimum spanning tree T, you do the following. Step 1, choose the arc of least weight. So you look at all your possible arcs. You've got 2, 7, 4, 8, 6, 4, 6, 9, 8, 5. Choose the minimum one. That's 2. And it says choose that arc. So what I'm going to do is I'm going to highlight it in. I've chosen that arc. Then it says repeat step 2 until you have n-1 arcs. So I've got 5 nodes here, so until I've got 4 arcs. The key thing here though, look at step 2. When I'm choosing those arcs, I've got to make sure that none of the arcs end up forming a cycle in my spanning tree. Else it would not be a spanning tree. Okay, what have I got left? Let's have a look. Well, I've got the minimum one, 7, 4, 8, 4, 6, 6, 8, 9 and 5. The smallest one is clearly one of the 4s, so I'm going to pick any one of them. Let me just pick that one there. I'll pick that 4. Okay, what's the smallest arc now? Well, clearly this 4 is now the smallest. However, if I included it, it would cause there to be a cycle. And step 2 says I can't choose any arc that would be a cycle. Hence, I'm not going to choose that one there. Okay, what's the smallest out of 7, 9, 8, 6, 6, 8 and 5? Well, it's the 5. So I'm going to include that 5 here. Okay, now I look for the minimum one. Well, I can't have the 6, otherwise it would create a cycle. I can't have this 6, or it would create a cycle. So I'm left with that 7, the 8, the 9 and the 8, and I've got to choose the smallest one, which is 7. So I include that one, and now I've got myself this following. I've got 1, 2, 3, 4. The 5 arcs are connected, and I've got the 5 nodes are connected, and I've got 1, 2, 3, 4 arcs as required. Repeat step 2 until I've got 4 arcs, and I've done that. Let's just check I've got the minimum. My spanning tree is AE, which is 2. It's BC, so I'll go from E. I'll go EC, which is 4. It's ED, which is 7, and it's BC, which is 5. Add those all up, and I get myself once again 18. And that, as in the previous video where I did prims, was the minimum spanning tree. Okay, all I've got for you now is 2 questions on Kruskal's algorithm. Please apply these and see if you get the correct answer. Pause the video, stop, it should take you about 5 minutes each one, and then see what the answers are. Here are the first questions. Pause the video here. And I'll show you the answers now. Here are the answers to this problem, and they are as follows. I'll just do the second one here for you. It looks the slightly more complicated one, so I'll do that just to make sure you can do it in case you didn't understand. Remember what Kruskal said. He said, look around all the arcs, choose the smallest one. So the smallest one is this one here, and I'm going to include that. He then says, look all the way around and find the smallest one. Looking around, the smallest one is then this 2 here. So I'm going to include that and circle it. Keeping on looking around, I've got another small one here. I've got that 3. And I'll circle it. Now what have I got left? I've got a 6, an 8, a 17. Looking around, I've got a 5 here. Again, that looks minimal of all the ones left, so I'm going to include that 5 and circle it. Okay, now what have I got? 12, 18, 19, 15, 14, 8, 9, 17, 6. 6 is the smallest now, so I'm going to include that one as well. Okay, now things start getting slightly tricky. Although 8 is the smallest one left, if I included it, it would create a cycle. This 15 would create a cycle. What else would create a cycle? Anything else in here that would create a cycle? Nothing as such yet. So the smallest of 19, 15, 17, 9, 14, 19, 18 and 12 is the 9. So I'll take that 9 and I'll include it. Okay, now let's see what I can have now. I can't have that 14 as it will create a cycle. And I couldn't have this 19 as it would create a cycle. So I'm looking for the smallest of 19, 15, 17, 18 and 12. The smallest there is clearly the 12, so I'll include that 12. Okay, now what could I include? Well, actually, I can see I'm nearly done now. The only thing I've got to include is this one in here. This 18 would create a cycle, and so I'm looking for the smallest out of these here, and the smallest is the 15. So I'll include that here, and I'll get myself the BC here. So hopefully this explained to you how to get this answer here. Just looking, see if I got the same as a computer. Indeed I did. The total length of that minimal one there is actually 53, and the arcs are CF, AD, GH, DG, AE, EC, HI and CB. So that is how you would have got the answer to that one. Thank you for listening.